Next we will construct a practical circuit of the NAND gate, and like before we shall treat it as just two gates. Here is our practical AND gate, but for it to behave as a NAND gate we have to make a couple of alterations with the resistor R3 and the LED. R3 is connected to the positive rail and the collector of TR2. The LED is connected between the collector of TR2 and the negative rail. Now we must be careful since this is polarity dependent, so we must make sure it is connected correctly. The positive side must be connected to the collector of TR1. The other end will be connected to the negative rail through a link, and that completes our connections. Now we shall run through the circuit. We connect the battery and current runs through R1 to SW1, which is open, and TR1 remains off. Through R2 to TR2, which also remains off. Through R3. Since there is no path through these transistors, current passes through the LED and back to the battery to complete the circuit and the LED lights. So with an input of 0 and 0, the output is 1. SW1 is now closed and current can flow to TR1 and switch it on. Current continues through R2, but as the SW2 is open and TR2 remains off. Current then flows through R3, and again, since there is no path through TR2, the current continues through the LED, which then lights. So if the input is 1 and 0, then the output is 1. Next, SW2 is closed. Current cannot flow to TR1 as SW1 is switched off. But current can flow through SW2, switching TR2 on. Current flows to R3, but there is still no direct path through both transistors, so a path is made through the LED to the negative, which then lights. So when the input is 0 and 1, then the output is 1. Finally, when both switches are on, this means that both transistors are also switched on. Current then flows through R3, but as both transistors are now on, causes a voltage drop across the LED and the LED fails to light. So if both inputs are 1, then the output is 0.